Okay, so this is the Organic Chemistry 1 Exam 2 review slides. So about that for for spring of 2016. So about that. So here we go. So one of the first things we're going to do for the free answer parts is going to be naming the compounds, right? So you have to for the cycloalkanes. The first thing you got to do is got to make sure that the ring, right, is larger than any of the straight chains. Now, the carbons are either part of the straight chain or they are part of the ring. You can't go in. You can't go inside, or you can't mix and match. All right. So with that, so for here, the ring would be 1, 2, 3, 4, 5, 6, and the straight chains would either be 1, 2, 3, or 1 here or 1 here. Since this is right, since this ring is larger than any of the chains, right? So with that, so this is going to be our main. This is going to be our main chain, right? It's six carbons large, right? So it'd be so that'd be C6, which normally would be normally be hexane, right? But since it's a cyclic compound, we have to add the prefix cyclo, so it becomes cyclohexane. Okay, so by that, so now that means that we have three side chains here, right? So this one here is 3 carbons long, right? So that makes it propyl. Okay, and then we have these 2 individual methyl groups. This isn't an ethyl group. These are 2 individual methyl groups. So methyl. Okay, so now we need to figure out the attachment points, right? So it's not like a straight chain where you start on one side and you start on the other. You don't know where carbon 1 is. So what you do is you say, okay, each carbon that has things hanging off of it, you're going to say, okay, we're going to say that's 1. So with that, so in this case, right, so we're going to say, okay, this one's 1, and then you either go clockwise or clockwise towards its nearest side chain neighbor, right? So the nearest side chain neighbor is over here, so it becomes 1, 2, 3, 4, 5, 6. Right, so that means this propyl group is hanging off of carbon 1, and these 2 guys are hanging off of carbon 2. Okay. Now, alternatively, right, you could say, well, what if this is number 1? That carbon's number 1. Well, then you need to go, in this case, counterclockwise because the nearest side chain neighbor is here. So it becomes 1, 2, 3, 4, 5, 6. All right, so here we go. So it becomes 1, 1, 2. Okay, so you add them up, and you say, okay, this is 5. This is 4. Since this is the lowest numbering, adds up to the lowest number, right? We're going to use those numbers. Okay, so it becomes, right? So so methyl comes before propyl. So we're going to have, it's going to say 1, 1 dimethyl, 2 propyl, cyclohexane. There you go. That's the name. Okay, now in here, right? Don't forget you can always put in the dots for the carbons, right? Okay, so here we go. So the ring here is 1, 2, 3, 4, 5. Okay, and the straight chains are either 1, 2, 3, or 1. Okay, so again, the ring is going to be the main chain, right? And it's 5 around, so C5. That would normally be pentane, right? But since it's cyclic, we're going to call that cyclopentane. Okay, so that means we have two side chains here and here. Right, this one, right, it's 3 carbons long, so it's propyl, but it doesn't look like this, propyl. Okay, so we have to indicate that because what's happening is, right, so we have 1, 2, 3, right, just like we had 1, 2, 3 there. Okay, here it's connecting through carbon 1. Okay, so at that connecting to the main chain through carbon 1, right? So we just call it a propyl group, or you could call it a 1 propyl group. Here, since you're connecting to the main chain through carbon 2, we call this a 2 propyl group. You could also call it an isopropyl group. I like 2 propyl because it's a little more descriptive. So like that. So this is a 2 propyl group. It's a propyl because it's 3 carbons long, and it's connecting to the main chain through carbon 2. Okay, this one here, it's 1 carbon long, so it's methyl. Okay, so just like this, you have to go in and you have to say, okay, if a carbon has a side chain hanging off, what happens if that's number 1? So we're going to say, okay, so if that's carbon 1 here, so we're going to go clockwise because the nearest neighbor is here. So nearest side chain neighbor, so 1, 2, 3, 4, 5, right? So that means that 2 propyl group is 2, hanging off of carbon 1. The methyl's 3. Okay? This case, right? So if you have the, we're going to say, okay, well, what if this is 1? Well, then we go counterclockwise, 2, 3, 4, 5, right? Because the nearest side chain neighbor is counterclockwise to it. If you went this way, it would be 1, 2, 3, 4, right? So lowest number. So this is 3, 1. Okay, so you have a 4, 4. You have a tie. Okay, so, and there's no way to break it. So what they've decreed is to say, okay, the one that starts first alphabetically is going to get the 1. So in this case, methyl comes before propyl, so we're going to use these numbers here. So it becomes 1 methyl, 3, 2 propyl, okay, cyclopentane. Right? So just like we bolted this number here, we're going to bolt, or this name here, we're going to bolt this whole name here. Okay, so it's a 2 propyl group connecting through carbon 3. Just like this is a methyl group connecting to main chain on carbon 1. Okay, so like that. So here's your name. Okay. Now the other thing you're going to want to do is come in here and you say, okay, I'm going to give you a name, and you have to draw the structure. Okay, so propane, right? Propane, this is 3 carbons, right? But again, it's a cyclo, so it's a 3 carbon ring, so it looks like a triangle. Okay, and you could, right? So then we're going to say, okay, well, we're going to say this is number 1, number 2, number 3, right? So you usually want to go backwards on these things, and you can set the carbon 1 wherever you want. Okay, I don't mind. So we're going to say, okay, we're going to have a methyl group hanging off of carbon 2, so that would be 1 carbon long, right? And then we're going to have an ethyl group, right? Just like this one was off of carbon 2, this ethyl group is hanging off of carbon 1, so you need a 1, right? So a 2 carbon side chain. So there we go. There's your structure. Ta-da! Okay. So for this one, I'm going to have a molecule. I'm going to point to a carbon and say, is that carbon chiral? Right? So like that. So what do we need? We need 4 different things hanging off of it. Okay? So like that. So okay, so this carbon here, right? You say, oh, well, there's only 3 things hanging off it, right? The carbon needs 4 bonds. And in the skeletal structure, right, I don't have to write the hydrogen, right? So there's actually the 4th bond on that carbon is going to be a hydrogen. Okay? So this one's going to be down here, CH3, this is a CH2, this is a CH. Okay, again, 3 bonds shown, so there must be an H there. Okay, so first thing you do is you look at the things that are hanging directly off of it, right? Right, you have an H, a CH3, a CH2, and a CH. Those are definitely all 4 different, so that means this guy's chiral. Okay. Okay, so let's look at this one here, right? Again, 3 bonds are shown, right? So that means that there's a hydrogen here that I don't have to show, but it's definitely still there. Okay, so again, you have CH3H, right? This has 3 bonds shown, so this is a CH. And then this one only has 2 bonds shown, so it's a CH2. So you have a CH3, an H, a CH, and a CH2. You know, CH3, CH2, CH, and an H. 4 different things. That means this is chiral off of that carbon. Okay, so here we go. So this one, right? So 3 bonds are shown, so that means that there's another H here, right? That I don't have to write, but it's there. Okay, so we're going to look on either side. So this is a CH2 and this is CH2. Well, okay, so we have, right? So we have a CH3, an H, a CH2, CH2. Okay, so we're going to compare these 2 guys, right? Those are the same. So now, so when you have something similar, that doesn't mean it's not chiral necessarily. What you have to do is you have to come out one extra atom out, right? So here it's a CH versus a CH, right? 3 bonds shown, right? So with an O, you know, this it's a CH with an OH hanging off of it. This is a CH with an OH hanging off of it, right? So these 2 guys are the same. So then we have to come down here and it's CH2, right? But coming this side and this side, they're both the same, right? So CH2, CH2, CH, CH with each side have an OH on it. Then it comes down here to a CH2, and you're done, right? We've come to the end of basically the end of our chain. So that means this side is exactly the same as this side. So since there's only 3 different things hanging off of it, this is non-chiral. Okay, this trick of coming out here. So if let's say this OH wasn't here, right? You'd say those CH2s are the same, right? And then you come out here to the blue carbons, and this would be a CH2 versus a CH, then it would be chiral. Because this side would be different than that one, right? Because this one would have an OH over here, this one wouldn't. But since there's OHs on both sides, so be it. Okay. Okay, cis and trans. Okay, so this, right, so cis means either up, up, right, or down, down. This means one up, one down. Okay, so with that, so here we go, right? So these 2 OH groups, right? So this one's going up, right? Right. This one's up, up, right? So it's pretty easy to see on the cyclopentanes here. So with that, so up, up, right? So this is going to be cis. Okay, here we go. Now on the cyclohexanes, okay, you have to separate out the idea of cis and trans and axial and equatorial. Okay, so axial and equatorial will be able to help you tell if it's up or down, but you can have 2 things that are cis and be equatorial. You can have things that are equatorial or be cis. That's one axial, one equatorial. Cis and trans are different than axial and equatorial, although you need axial and equatorial to be able to figure out cis and trans. Okay, but they're 2 separate concepts, so you need to keep those separate in your mind. Okay, so here we go. So remember on the cyclohexane, right, we always have an up and a down. Okay, so with that, so here we go. So for this chlorine, right, so the bonds are pointed up. The carbon-carbon bond's pointing up, so that means the axial is up. Okay, that means the equatorial is coming, right? So that means the axial's up, so that means that the equatorial is down. Okay, same goes with this one, right? The carbon-carbon bonds are pointed up, so they always point towards the axial, since the bonds are pointed up, right? So that means this is up, which means that whatever's in the the hydrogen that's in the equatorial position is down, right? Since it's up, up, that means it's cis. So we have 2 axials that are cis. Okay, but for here, right? So the the carbon-carbon bonds are pointed up, so that means that there is an axial up, right? Which means this one is down. The OH is down. Right? You always have to have an up and a down on the cyclohexane. For this one, right? The carbon-carbon bonds are pointed down, so that means the axial is down. So that means this equatorial is up, right? So we have a down and an up, so that means that they're trans. Okay, so we have 2 axials that are cis, 2 equatorials that are trans, and so you have to keep those things separate. Okay, you have to figure out which one on each one of these, on the carbons of interest, which one's up, which one's down. You can do that using the axial and equatorial. So with that, but they're 2 separate things. Okay, all we're doing for cis and trans is looking for up and down, or up and up. Okay, here we go. Now, for R and S, okay, so with that, so here we go. So there'll be an arrow pointing to the carbon of interest, right? So with that, so here we go. So remember, we need to we're looking at the first thing we got to do is we have to look at what's right on, hanging directly off of that carbon. So in this case, it's a hydrogen, a chlorine, right? In this case, it's a CH and a CH2, right? So it'll be carbon-carbon, right? Carbon-carbon. Okay, so the heaviest thing of these things hanging off is this, right? Is this chlorine, right? Then it's going to be one of these carbons. We don't know which, but the hydrogen's going to be the lowest. Okay, so now what we need to do is since these are a tie, we look at the bonds. So for that one, right? So with that, so we have 2 carbon-carbon bonds and 2 carbon hydrogens, right? This guy here, right? It would be 3 carbon-carbon bonds, right? 1, 2, 3. So there's one right there, there's one right there, one right there, and 1 carbon hydrogen. Okay, so you look at the bonds, right? So you say, okay, well they're both carbon-carbon bonds, so that's a tie. But this one has 3 of them, while this one only has 2 of them, right? So since this has more heavy bonds than that one, so with that means this is number 2 and this is number 3, right? So I'm gonna redraw this with just the numbers. So 1, 4, 3, and 2, right? So if you're doing the steering wheel method, right, 4 has to go behind, has to. Okay, so it's going this way, 1 to 2 to 3, right? So it's going this way, it's clockwise, so that would make it R. Okay, if you're doing the hand method, right, 1 is up here, 2 is over here, 3 is over here, right? You have to stick your thumb where 4 is, okay, point 4, and then you go 1 is up here, right? 2 is over here, 3 is over here, right? So you sweep 1 to 2 and around to 3, right? Usually if you get 1 to 2, you're fine. So you'll sweep 1, which is up here, 2 is over on this side, so 1 to 2. Since I'm sweeping with my right hand, it's R, right? I can't sweep with my left hand and go 1 to 2 there, right, and break my hand, right? So 1 to 2. Okay, so with that, I can't sweep with my left hand. I have to sweep it with my fingers. Tips will sweep from 1 to 2 to 3 around. So that means it's R. Okay, so here we go. So this next one, right? So we have a CH, or excuse me, a CH2, CH2, CH2. Okay, so with that, so right, so carbon, 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 hydrogen. So we don't know which one of which of these it is. Okay, so with that, but we do know that this is going to be 4. Okay, we just don't know which one is those. Okay, so we're going to look at this first one here and say, okay, this one has 1 carbon-carbon bond, right, just right there. 2 carbon hydrogen, right, and then 1 carbon chlorine. Okay, right there. This guy there, right, has 2 carbon-carbon, 2 carbon hydrogen, right. Then this one, 2 carbon-carbon and 2 carbon hydrogen, right? So we're going to take a look at this, right? So the heaviest bond, and this one is carbon-carbon, this one is carbon-carbon, this one is carbon-chlorine. Even though there's only one of them, it's carbon-chlorine. Since chlorine's heavier, that makes this 1, the higher priority than these 2. Okay, but they're both carbon-carbon, and they're both 2 of them, right? So that means, well, there's a tie. So whenever there's a tie, we move out 1. Okay, so now we're going to go out for this one, right? This is CH2, CH3, right? So here, right, this one has 2 carbon-carbon bonds again, and 2 carbon hydrogens, right? This guy there, right, has 1 carbon-carbon bond and 3 carbon hydrogen bonds, right? So now we're looking at the black information here, right? So with that, so this one has 2 carbon-carbon bonds. This one also has carbon-carbon bonds, but this one only has 1 of them. So in this case, that makes this a higher priority than that. So it becomes 2, 3. Okay, so if we redraw this, 4, 3, 1, 2. Okay, so again, so if you're doing the hand method, right? So the right, the 4 is coming out at you. Okay, the 1 is over here, 2 is over here, and 3 is up here. So it's going to sweep like that with your hand. So you can actually turn this around, right? Make it a little more comfortable for you, right? So the 4 is coming out at you. 1 is over here, 2 is over here, and 3 is there. So you're going to sweep 1 to 2 to 3, right? 1, 2, 3. Since I'm sweeping with my right hand, again, it's R. Now, if you were going, now, if you're going to do the steering wheel method, right? You're going to say, oh, well, that's counterclockwise. Why is that R? Well, but again, this 4 is coming out at you. Okay. In order to do the steering wheel method, you have to rotate it around, so 4 is behind. Okay. So here we go. So we're going to say, okay, this is 1, this is 2, this is 3. Okay, so when we turn this around, 3 is going to still stay where it is. Well, sort of. It's just going to come forward from coming behind. Okay, but 2 is going to switch places, right? So 2 is going to come over here, right? So 2 is here, 1 is here, right? And 4, right, is coming behind. Right, so now notice how we're going clockwise. So that means it's R. Okay. Okay. Now for this one, right, what do we have, right? So we have a fluorine, a hydrogen, a bromine, and a CH2, right, a carbon, right? So what's the heaviest? Well, you look on the periodic table, right? This is going to be the heaviest. Then this one, then this one, then the hydrogen. Okay, so let's read. Well, that's not so bad. Okay, so in this case, right? So 1 is behind, 2 is coming up, and 3 is over there. Okay, so 1 is behind, right? So, right, I'm going to turn this so I can and do this, right? So your thumb is going to point towards the 4, right? So 1 is behind, 2 is up, and 3 is over there. Okay, so 1 is behind, 2 is over here, 3 is over there, right? So 1, 2, 3. Since I'm sweeping with my right hand, or excuse me, my left hand, that makes this S. Okay, and again, if you want to do the steering wheel method, okay, so we're going to say that's 3, that's 1, and that's 2. We're going to rotate this around, right? So now the 3 is up, right? So the 2, which was out, comes over here. 1 is here, and then 4 is behind, right? So since we're sweeping counterclockwise, right, it's S. Okay? So it went 1, 2, 3, sweeping around. So there we go. Okay, so here we go. So what we're going to be doing here, right? So that's not a chiral center. That's not a chiral carbon, right? Because there's 2 hydrogens on it. But what we're going to do is we're going to say, okay, what if we're going to make one of those special? Okay, we're going to make, let's say, this one special. Okay, how does it make? What does it do to the carbon as far as making it R and S? Okay, so here we go. So we're going to say this one's the special one, the one coming forward, right? I'll show you in a minute why I usually pick that one. Right, so here we go. So 1, right, so that's CH2, CH3, right? Right, those are both carbons, right? But this one has 2 carbon-carbon bonds and 2 carbon hydrogens, right? This one has 3 carbon-carbon bonds and 1 carbon-hydrogen bond, right? So this has 3 versus 2 carbon hydrogen, right? So that makes this 1 and that's 2, okay? Now we've got this dilemma of saying, well, these are both hydrogens, both the same. But let's say instead, let's make this one 3 and this one 4. You just pick one. Doesn't matter. Pick one. Okay, so that makes this, that would make this carbon, right? Right, so here we go. So if you're going to do the steering wheel method, right, if you pick the first one to be the special one, that makes the 4 go behind, right? So by that, so that would mean it's sweeping around like this. So if you're doing the steering wheel method, right, it's going clockwise, so that makes it R. Okay, again, if you're doing the steering wheel method, I'm going to twirl this around, make it a little bit easier, since I know it's R, right? So like that, so sweeping the right hand, right? So 4 is going behind, right? So 1 is over here, 2 is over here, 3 is over here. So go 1 to 2 to 3, right? So sweeping with my right hand, 1 to 2 to 3, 1 to 2 to 3, right? Since I'm sweeping with my right hand, that means that this new chiral center that we made that was here, right? When 3 is special, this carbon becomes R. So that means that this is the pro-R. Okay? You always have a pro-R and a pro-S, right? So that means this one is pro-S automatically. Now if you instead say, okay, let's make that the 3 and that the 4, right? This carbon would become S, right? Which is why it's the pro-S. Okay? Whichever one you say, so you take this, you say, okay, one of the hydrogens is going to be special. We're going to make that 3. Then you say, okay, what does that do to this carbon? That turns it into R. So that must be the pro R. Okay, so they always come in pairs, so that means that if this is the pro R, then that one has to be the pro S. Not too bad. Now you can also do this with the sp2 hybrid, right? So with that, but here, right, you're going to have faces, right? Because there's only ever going to be 3 things hanging off. Okay, so here, right, there's a CH2. Don't forget that there's a little kink there, so there's a carbon, right? Oxygen, carbon here, right? So carbon, oxygen, right? Oxygen's gonna be the heaviest, so that's gonna be 1. This CH2 here, right? This has, right, 1 carbon-carbon bond, right? 1 carbon chlorine and 2 carbon hydrogen, right? This guy here also has 1 carbon-carbon bond, but it has 3 carbon hydrogens, right? So you say, okay, that's the heaviest bond on this one is carbon-carbon, this one is carbon-chlorine, right? So this is going to be a higher priority, right? So this is going to be 2, this is going to be 3, okay? So we're going to say, okay. So that means 1 is over here, 2 is out here, 3 is here. So we're going to say, okay, we're going to look at the top face, okay? Right, so it's going to sweep out this way. Okay, so 1 is over here, 3 is up here, and 4 is behind, right? So what you need to do with your thumb is to say, okay, your thumb points to which face it is, right? Thumb points with the arrow. Okay, again, I'm going to turn this to make it a little bit easier. Right, so, let's see. No, it's going to be this one, right? So your thumb has to be pointed towards there. So 1 is over there, 2 is up here, right, because it's coming up out of the face, and 3 would be behind. Right, so 1, 2, 3. Since I'm sweeping with my right hand, with my thumb pointing towards the arrow, sweeping with the right hand, 1, 2, 3. That makes this face the ray face, right? Just like R is, right? So R is with your right hand. The if you're sweeping with faces, it's ray. Okay, it's short for it. Right? So R actually stands for rectum. S stands for sinister. Okay, for the R and the S, right, they just took the first letter. Here they wanted to indicate that it's a face, so they just took the first 2 letters, here and here. That's all they did. But it's the same concept. If you're sweeping with your right hand, it's R. And again, they come in pairs, right? So the other face has to be the C face. Okay, so if you figure out if you figured out this one was the C face, then you know automatically that's the ray face. So there you go. Okay, so for next one is going to be a meso compound. Okay, so what you're going to want to do is you're going to want to add wedges and dashes. I'll have a better explanation for this, but add wedges and dashes as appropriate to make this compound meso. And remember, and then indicate with a dashed line where that plane of symmetry is, right? So there you need a plane of symmetry so that the one side of the molecule is the mirror image of the other. Okay, so in this case, what you're going to want to do is add, put, say, the methyl groups, both going up. You could also do both going down too. That's also, it's actually the same molecule just turned over. Right? So now there's a nice plane of symmetry that's going right there. Okay, so this side of the molecule is the same as this side. It's just a mirror image of it. And so here we go. Right? This one, if you were to put the, let's say 1 up and 1 back, right? That plane of symmetry is now broken. Okay, this is not the mirror image of this, right? So because here, if you took the mirror image on this side, right, the CH3 would be coming up. Okay, which we don't see. So this is actually chiral. So this is meso, and this is chiral. Okay, so this is the one we want for this problem. Okay, a nice, indicate the plane of symmetry with a dashed line. It's not going to get more complicated than this. Now you can slice it through. Okay, so let's say I put a chlorine here. Let's say if there was chlorine right there. Right? There's still going to be the plane of symmetry here, and you can literally slice through that chlorine. That's not a problem. Okay, so that's right. So these CH3s, right? So they're underneath, right? So it's a plane of symmetry, right? There we go. So this is also meso as well. Okay, don't be afraid to slice through an atom. Okay, now for this one, right? So nucleophile, right? What do we need for that, right? So nucleophile is what? It's loving positive charge, so that makes it negative character. Right? Electrophile, right? What loves negative charges? This positive things, right? Positive character. Okay? So you need to look at the periodic table and say, okay, what are the bonds, right? So if I'm interested in this one, so what is bonded to it, right? So, and what's the electronegativity telling us? Okay, so here we go. So carbon-carbon, right? So that's gonna be a covalent bond. Here there's a polar bond between this carbon and oxygen, right? So oxygen is more electronegative, so it's going to have a negative charge, and this is going to be so that if this is pulling electrons with it, right, that's going to leave a positive charge, a partial positive there. Same goes with this one, right? So there would be a partial negative here, which puts a partial positive there. Okay, so since this is a partial positive, right, it's positive character. That makes this the electrophile. This has negative character to it. It doesn't have to be a negative charge, but at least have negative character to it. So that makes this a nucleophile. Okay. So same goes with this one, right? So this carbon, right? So compared to that, or that chlorine compared to that carbon, right? So the chlorine is going to be a little more electronegative, so it's going to be negative. This is going to be positive, partial negative. So there's negative character to it. That means that this is the nucleophile. There you go. Okay, so for this one, right, so I'll actually show you what the reaction is, right? So it has two intermediates. So it's really like A to B to C to D, okay? So it has two intermediates here, right? So the second step of the reaction is slower than the first or the third, okay? So that's gonna be important, right? So to indicate which one's the slow reaction. So that's one of the important pieces. The other one, the overall forward reaction, is non-spontaneous. Okay, so it's non-spontaneous. Okay, now you have all the information, right? So what this is going to tell you is where, if the energy of the products, right, is going to be higher or lower than the reactants, right? So since it's non-spontaneous, that means it's higher. Okay, so here we go. So we're going to plot, right, energy versus reaction progress here. Now, these are all relative things, right? So, so you usually put the reactants about a third of the way up. Reactants. Okay, so we need to label reactants, intermediates, products, transition states. Every time you have an arrow, that's a transition state. Okay, the overall free energy and the overall activation energy, right? So, so the delta G's, okay, are always relative to the reactants. Okay, so it's always going to be relative to here. So there's going to be an activation energy that's way up there, okay? And then your spontaneous, non-spontaneous, so this one is relative, you know, to here. The overall activation energy is going to be, is always going to be sort of way up here, like that. Okay, your products, right, since it's non-spontaneous, is going to be above, just somewhere above. So this is products. Right, so that means this guy here, right, is delta G0, right? It's all the delta G's are relative to the reactants. It's not relative to the bottom of this axis. It's always relative to the reactants. Okay. So here we go. So we have reactants, products. So we have that done, reactants and products, right? We have two intermediates here, right? So we need two little bits here. So these are the intermediates. Okay, there and there, right? So we got those. Okay, so now we need the transition states. Okay, so those are the humps. Now we know that first, second, third. We know that the second reaction is the slowest, right? So the second step of the reaction is slower. So it's always going to be the slow step that touches this upper bound, okay, the delta G double dagger. Okay, so that means that everybody else, it's still a hump, but it's going to be lower than it. right? So it's going to look like that. It's going to look like a 10-gallon hat. Okay, so there we go. And then these guys are the transition states. Right? If you have 3 arrows, you need 3 humps. Okay, so there's one here, there, one there. And there you go. Got that taken care of, right? So the delta G's are always relative to the reactants, right? The slow step is always going to it's going to be the step, the hump that gets to this here, right? So it always touches this transition state, right? And the spontaneous, non-spontaneous, right? It's non-spontaneous is going to be above here, and again, it's going to be relative to the reactants. It's going to be up there. So there you go. Okay, so curved arrow mechanism, right? Like that. Okay, so here we go. So right? So this one here, right? So since you have 4 electrons smashed into here, right? This is going to have negative character to it. I'm going to go ahead and draw on these hydrogens because it shows a little bit easier. Okay? Right? And again, and then on this one here, right? So this one has more electronegative, chlorine, and so this hydrogen is going to be more electropositive, right? So what we're going to happen is, I'm just redrew it down here. This chlorine, or this negative character is going to be attracted to that positive character there on this hydrogen, right? It's going to make this bond, make a bond with this hydrogen, right? But hydrogen only needs 1 bond, so it needs to figure out what to do with these 2 electrons. So what it does is it pushes it onto the chlorine. Okay, so you end up with this. Right? And notice here, like, here's the hydrogen, right? Hydrogen, right? Right? So you had 1 hydrogen, 1 hydrogen. Now we have 2 hydrogens and a chlorine and a hydrogen, right? So these guys, this hydrogen and chlorine came from here, right? So we're going to say that hydrogen, right, is going to go here, right? And since this has only 3 bonds to it, that carbon has a positive formal charge, right? The chlorine, right, now it hasn't, right, so these 2 electrons became this new set of lone pairs. That actually gets a negative charge. Okay, so we're going to turn this, one of these sets of electrons, or lone pairs, doesn't matter which. These guys are going to come in and back react to that, right, because you have negative and a positive that can be react towards each other, and there you go. That's it. That's all it is. So there you go.